Theoretically, both a Pigouvian tax and cap and trade can obtain the optimal level of pollution in the simplest models that abstract from uncertainty. However, Weitzman showed that this equivalence no longer holds when regulators do not have full information on abatement costs of reducing emissions or full insight in the avoided damages. With uncertainty, the relative performance of taxes or prices and caps or quantities depends on the relative curvature of the cost and benefits curves of abatement. Let's try to make sense of this by decomposing the following figure taken from toll. Let us draw some assumed marginal cost curve for emission reductions with emissions on the horizontal axis and prices on the vertical axis. Here, the idea is that reducing emissions to zero becomes increasingly expensive. It makes some sense that the marginal benefits of emission abatement increase with emissions. Or put differently, we can expect the marginal damages of emission to increase with emissions. It is not really necessary that these lines are linear. Weitzman expressed his theorem more general. However, for the sake of reproducing toll, his figures, let's say they are linear. Based on this information, the regulator can either choose the optimal price for carbon in the form of a carbon tax at P1. Those emissions that cost less to reduce than the tax will not be emitted until the point Q1 is reached. Or the regulator could have opted for the other instrument of capping allowable emissions at Q1. In this case, if the assumed marginal abatement cost were correct, a market price of P1 would emerge. Now imagine that due to some breakthrough technology, the true marginal abatement costs turn out to be lower. In this case, the welfare loss due to either over-regulation or under-regulation differs by policy instrument. Would the regulator have known the true marginal abatement cost, the choices of optimal tax or cap would give a price or a quantity of P and Q star respectively. Yet the tax had already been set at P1 or the cap at Q1. Consider again the earlier set cap of Q1, which allows for more emissions than the new optimal Q star. In this case of under-regulation, firms will trade under the cap until the market price P2 emerges, and only cut emissions until the now inefficient cap of Q1. The welfare loss of under-regulation equals this red triangle. That is, at Q1, the marginal damages of emissions still outweigh the marginal cost of abatement. So reducing emissions further until Q star would have been welfare enhancing. Similarly, if we would consider the tax set on the old information again, we would see that the tax was set at a higher price than optimal, and as a result encouraged emission reductions beyond the point that these reductions still outweigh the marginal damages. Again, the policy set on outdated information leads to a welfare loss, but this time of having committed to a policy that was too stringent for economic activity in retrospect. And so we're back at the figure by toll, and the welfare loss of either over or under regulation appear to be the same here. However, the expected welfare losses of over or under regulation start to look different when we change the slope of the marginal benefits relative to the slope of the marginal cost. And you can see that the relative attractiveness of either taxation or cap and trade starts to depend on how we expect the curvature of the abatement and damage functions to look and what type of error may be more frequent. One argument expressed by Toll on page 56, climate change is driven by the stock of emissions. That implies that the marginal impacts of climate change do not change much if emissions are reduced or increased by a little. The regulator should therefore levy a carbon tax rather than create a market for emission permits. Put differently, Weitzman theorem gives arguments for using a carbon tax, but also to establish a cap and trade market for methane emissions that have a much shorter atmospheric lifetime and therefore weaker stock properties. Moreover, methane is a greenhouse gas that is 25 times more potent than carbon dioxide. In summary, both Pigouvian taxes and cap and trade introduce prices for previously unpriced externalities, and in this way both instruments can help to address an important market failure. Although theoretically equivalent in a simplified setting, both instruments have their advantages and disadvantages. In addition to the influence of uncertainty that we have just explored with Weitzman's theorem, there are some relative advantages to either instrument. It has been argued that the administrative cost of creating a market for allowances is higher than monitoring a relatively simple tax. However, the amount of emission reductions from the tax remains more uncertain. By contrast, the certainty in emission reductions from cap and trade comes at the cost of price fluctuations on the allowance market. These price fluctuations are argued to be bad for investors, while to their merits, it does serve a counter-cyclical role. At the same time, these fluctuations can be alleviated by incorporating price ceilings or floors for emission allowances.